Mr. Covey here, and this is going to be a real quick video. I just want to show you how you can think about limits numerically based on a table. Okay, so instead of looking at a graph, we're looking at a table here, and I don't think this will be too bad. So my first question here is, based on this table, what can you conclude? Okay, I want you to pause and think about that, and then I want you to answer that second question too. Are you 100% positive that what you said is true? So pause, take a minute. What can you conclude based on this table? What is it kind of leading you to say? And then are you positive that's true? Okay, so what you might have said was, oh, well, based on this table, it looks like the y value, the f of x value, when x is 3, it's got to be negative 3. It's got to be. Look, this is like negative 2.999, and this is negative 3.0. This y value has to be negative 3. In other words, it's very tempting to conclude that f of 3 is negative 3. If you should be able to fill in a negative 3 right there. What I want to caution you about is we don't know that's true. It sure looks like it's true. But there's a reason that they put a little question mark there, and that's because there might be a hole there. There might be a hole in the graph. So we actually can't say that. We want to be able to say that, but we cannot say that. What we can say, though, is that as your x values get close to 3, your y values are getting close to 3. So what can we actually conclude is a limit statement. We can conclude based on this table, and you can look at it and say, hey, as your x values are getting closer to 3, our y values, our f of x values, are getting closer to negative 3. That is definitely true, okay? And notice that we have x values getting close to 3 from the right, and x values getting close to 3 from the left. And in both cases, these are getting closer and closer to negative 3. Okay. Make sure you slow down and you think about it like, oh yeah, 2.9999 is closer to 3 than 2.999. You guys know that, like that's just some number line, draw a number line, use some number sets. Cool. So this is what we can actually conclude based on this on the table, and we're 100% positive that's true. Yes, this is true. This might be true, but we're not sure because there might be a hole in the graph. Okay. And that's it. That's how you evaluate a limit based on a table. Let's do another one together. So if you look at this one, just make sure we're keeping this all straight. What x value are they trying to show us about? Well, 4.5, 4.9, 4.99, 5.1, 5. Oh, they're really trying to talk to us about what happens when x is 5. Right? Like they're having our x values get close to 5, both from the right and from the left. So they want to talk about what's happening when x equals 5. Again, it's tempting to look at this and say, oh, it's just 8. We don't know that. We don't know that. We don't know that. It could be a hole in the graph. What we do know is that as our x values are getting closer to 5, our y values are getting closer to 8. That is definitely true. This limit statement is definitely true. 2 more examples here. Sometimes they're not going to give us a table. We have to make the table ourselves. I'm going to show you how to do that on your graphing. It's pretty easy. Hit your y equals. Type in the equation. I would like you to do this on your graphing calculator, not on Desmos or something else. Oh, just easier to do it this way. Thank you, thank you. Okay. Now we're going to go to our table. We're going to hit second graph to go to our table. And the problem is, like, you want to know what's happening as our x values get close to negative 2. But if you look at your table, like, at an x value of -2, there's an error. And then, like, we don't really know a lot of x values that are right around -2. Like, they give us x as -1 and 0, like, but they're not getting us close enough. You know what I'm saying? Like, if I want an x value that's really close to -2, I want, like, -1.999. And they're not showing me that in the table. So you can change that. And I don't know if you guys know how to do this, but pay attention if you don't. If you hit second window, it takes you to this screen. And what you can do is change the independent to ask. Okay, so I clicked over and hit enter. And now when I hit second graph and go to the table, it's going to ask me what x values I want. Which is perfect, because I kind of want to make a custom table here. Think about it this way. I want to get really close to -2. What are some things smaller than -2, but getting close to it? Well, I could do like -2.1, -2.01, -2.001. And what happens as I approach -2 from the right, from the bigger side? Be careful. -1 point, I don't know, 9, -1.99, -1.999. You don't have to use those values. But what you do have to do is make sure that you're picking x values that are approaching -2 from the right, from the left. Think about a number line, and I hope this makes sense. Okay? So now I'm going to fill out this table using my graphic calculator. Calculator can do this all for you. It's very nice. I'm just going to toss in the x values that I want. Okay. And once you do that, it's going to be, it's going to be easy. It's going to be just like the last one. The calculator is going to spit out what we want. Yeah, I'm going to copy down those values. And you can do different rounding and stuff if you want. But hopefully you get something that looks similar to this. What this is telling us is, as our x values get close to -2 from the left and right, our y values here are getting closer and closer to 0.5 to a half. Okay, or you can write 0.5. So we're evaluating that limit not by looking at the graph, but by looking at a table here. Okay, we're making the table on our graph and calculator. I want you guys to pause and give this last one a try. If you're really stuck, I'll give you a hint here. Otherwise, pause and give this a try on your own. But if you're really stuck, start by picking out the x values. What's close to 1, but a little bigger? Notice I start over here, too. Oops, I should write that. Sorry. Right here. What's closer to 1, but still bigger? Well, what's closer than 0.1? 0.01. What's even closer? 0.001. Those are really close to 0. What is something really close to 0 that's smaller? Well, -0.1. What's even closer? -0.01. What's even closer? -0.00. Those are not the ones you have to use. You got to get the answer right. So whatever you use, you got to lead you to the answer, but I think these are good choices. Go to your calculator, type in this equation. Answer the question. Go ahead and pause and do that. Okay? So again, those are the x values that I used. Here are the y values I got out from my table in my graphing calculator. And from this table, I can look at this and say, well, as I approach 0, it's sometimes helpful to like write out, remember, 0 is right here. As I approach 0, from the right and from the left, what's happening to these y values? Well, from the left and from the right, both those y values are approaching -0.5, -0.5. Okay. So this is simply another approach to evaluate a limit. When they give you an equation instead of a graph, and they ask you to do a table, you can do this. Cool. We'll practice this, but I hope this isn't going to be too bad. Thanks for watching, guys.